I am the co-director of the National Sleep Research Resource. I also direct a program in sleep medicine epidemiology. I've had the privilege of being involved in multiple NIH-funded cohort studies and clinical trials, and it's through those experiences that I really became motivated and convinced about the need to share data and to create larger data sets of high quality. In fact, it's also particularly been my pleasure over the last 10, 11 years to co-direct the National Sleep Research Resource. And as you can see in the bottom of the slide, we currently have almost 50,000 sleep individuals with one or more sleep studies represented in our resource. We have over 9 terabytes of data, and we've shared more than 2 petabytes of data with hundreds of researchers and trainees across the globe. And as this snapshot of our website shows, is that we we have multiple ways to explore data here. We encourage sharing of data, and on an ongoing basis, we're ingesting and expanding our resource. And really, community engagement is also a key focus, and we really enjoy highlighting through blogs like the one shown in the middle of this page, research that really has been facilitated by accessing data within our resource. Now, the impetus over 13 years ago to start such a resource was the recognition that there is a huge reservoir of sleep and circadian data that continuously expands. In fact, it's estimated that there's over 1 million clinical sleep studies performed per year. And there's additional research data that are collected across really dozens of NIH and industry-funded sleep studies. And we all know that there's growing use of consumer wearables that collect millions of days of sleep data on millions of people around the world. But really, the real challenge from understanding what these sleep data mean and how we could utilize them to promote health is that many times these data can't be easily accessed or they're siloed. I'm particularly excited about sleep data for a few reasons. One is that sleep data is collected on several scales. So, for example, the polysomnogram is typically collected with monitoring of multiple physiologic signals over many hours. And some of the accelerometry, actigraphy, wearable-based data, that could actually include data collection over days. And what that allows is for the researcher to really explore and understand very interesting temporal and dynamic features about health and disease. But there's also, in many sleep studies, multiple channels of data. So you could see here in the middle of the slide, we have about 13 different channels of data that's being collected and archived, but it's collected from EEG data, EMG data, ECG data, breathing and oxygenation data. And so we not only can look at different physiologic systems, but begin to understand their crosstalk or interaction. And now, with the availability of better analytic tools, the sleep field has moved away from fairly reductionist metrics like summary metrics of how many times an event occurs or how much time you spend in a certain sleep stage to develop quantitative metrics that are much more powerful. So as one example, we now have metrics to quantify the overall hypoxia experienced in response to apneas called hypoxic burden, or the overall heart rate response to apneas in a very quantitative way. And similarly, when we think about sleep staging, once upon a time, we very simply looked at the times in these various stages of sleep from wake to deep sleep. And now we can actually look very quantitatively at the frequencies and the power across the night, which gives us a much more granular assessment. And this is an overnight snapshot really showing but in different colors, the different frequencies of EEG changes over the night, which do correlate with your these manual estimates of staging, but again, are much more quantitative and objective. Now, why share data? And I think we all agree that there are multiple motivations. We know that analyzing any individual data set really, is often too small, not diverse enough, and doesn't really allow for reproducibility. So as we, learn that our research needs to be rigorous and reproducibility, we need access to independent data. We need sample sizes now that are big enough to address outcomes in predictive and models and causal inference for outcomes, for example, such as myocardial infarction or death, which really often require combining data sets from multiple sources. And we also know we want to overcome biases and really have work or results that are generalizable by age, by background levels of diversity, and allowing us to address life course changes and disparities. And we also know there's much power and excitement about artificial intelligence and machine learning, but they do require both large data sets and diverse and representative data sets. So this is all fine and good. And so why does not sharing of large data sets not happen more frequently? And we know there's just the, historically challenges in accessing and harmonizing data, particularly sleep data. So as in other fields, there's ownership concerns, regulatory barriers, inconsistent standards in developing data documentation, and specifically related to sleep, but also relevant to other complex data types, there is really a lack of accepted sleep ontologies or terminologies. There isn't community-wide endorsement of common data elements. And in the data acquisition phase, there are different approaches for collecting signals in terms of how they're filtered, what sensors are used, how they're then scored and processed and represented. So if you're a user, you know that there's tremendous opportunities, as I said, with increasing statistical power and the, cost-effective approaches to rapidly repurposing data to ask novel questions and getting at that rigor and reproducibility. But then there are these other challenges. And in fact, what we seek to do in NSRR is to overcome some of these and, in particular, minimize logistical and technical challenges of both accessing and harmonizing data, and avoid the introduction of biases in analyses that could be amplified by analyzing insufficient data or data that's not adequately harmonized or understood by the user. In the article that I referenced in the beginning of the talk, we really address the NSRR approach in using the FEAR lens, the findable, accessible, interoperable, reusable principles to address these issues. And as I said, I'm going to now introduce the computational tools that we've begun developing, and then Dr. Kim and Dr. Zhang will talk about the other elements. So the analytic tools that NSR has, really focuses on is an integral part of what we see as an ecosystem that includes data sharing and community engagement. So it includes sharing well-documented open source tools. And in this way, I want to really give a huge shout out to the co-director of NSRR, which is Sean Purcell, who really is the #1 developer behind all these tools. And not only is he an Uber, and I think he does so well because he's also an Uber user and an incredible scientist. So he knows, I think he well appreciates what users need. So what Dr. Purcell has done is to develop a library of tools called Luna, and these are based on a core C++ power tool library that consists of a number of programs, and you may not be able to see them well here, but you go onto this website, but there are dozens of routines that allows the user to access the raw polysomnography data, that is the EDF, European Data Formatted Tools, files of scored annotations, and then do various data checks, cleanup, quality control, normalization, as well as analysis, including generating metrics such as EEG power density, spindles, and even automatically sleep staging the data. Dr. Purcell is also now extending the C++ library into an R library and a Python library. And as I'll show you too, he's also developed very powerful data visualization tools. And in addition to sharing tools, NSR believes strongly in sharing our pipelines. And by pipelines, we talk about the NAP, the NSRR automated pipeline. And this in particular has initially been developed to focus on polysomnography data, which, as I mentioned, is across labs across the world are notoriously in using various labels, referencing approaches, labeling channels, potentially inconsistently with units, and often saving or archiving the data in a way where there may be corrupt signals or artifact that was not otherwise flagged. So in fact, a lot of our pipeline is to use Lunar and a set of procedures to really allow for uniform annotation. And the key areas are to map our core signals and annotations to common terms and formats. And Dr. Purcell calls these our canonical data dictionaries. We also attempt to fix clear, unequivocal issues, like when clearly there's been some type of corruption or loss of channel. And then there are maybe more subtle issues that a secondary user may not be able to sort out, or actually maybe intrinsic biological variability, and we flag those. And so here, what I've really summarized is a series of data harmonization steps we take, really producing new versions of the raw data sets where in fact we apply some regular or some unequivocal cleanup and relabeling of our channels so it's easy to harmonize across the data sets, and other times where we actually also create a more uniform set where we re-reference and we set uniform sampling rates, again for actually harmonizing the signals themselves. And then there are times when it's very hard to fix, but we flag potential problems like inverse polarities or contamination of signals so users can more easily clean them in relevance to their own research project. And as an example here on the bottom, you could see some raw, a summary of data before it went through our pipeline. And this is our power spectral density from EEG across different EEG frequencies, with different colors being different studies. And it's very clear that there are a number of studies that are just noisy with a lot of high frequency power that we really would not expect to see. And then you could see how nice and clean and tight and similar across studies this power spectral density becomes after this cleanup. Now, a very useful tool that Dr. Purcell's also developed is Moonbeam. And Moonbeam directly pulls data either from your own computer or from the NSRR data into a browser. Moonlight particularly uses the NSRR data and then makes it available for analysis using Luna. And for example, a few simple steps, and you could look at this Earl on the bottom here to learn more about it, is you could use Moonlight to select your particular cohort. You could then actually identify, once you bring up the cohort, a given individual observation or ID, and look at all the data, much of which has been actually often with terms that have been harmonized for TopMed or BDC. You could even select and zero in on a per individual basis on specific signals to really check for abnormalities, contamination, or interesting features. Like here, you're focusing in on the ECG signal, the EEG, and 2 respiratory signals. And then also you could use a variety of tools to look at metrics over the entire night. And here, for example, you could look entire the night to actually do QC, and here is an ECG channel. It was clear that for some reason the ECG was lost right here in the middle of the night, and this will accelerate your ability to clean things up. And there's a lot on this slide, but I just wanted to give a big shout out again to Dr. Purcell that through Lunar, the user may access a variety of data wrangling tools that allows you to resample, re-reference, to do annotations, masking, and so forth. You might also have various analytic tools deriving hypnograms, for example, from different cohorts and individuals. You could use some of the interactive tools as well to explore the individual data sets and generate your unique features of EEG microarchitecture like spindle frequency and density. And there's even tools he's developing for high density EEG. And as we heard with the introduction, we are particularly pleased now to be working formally with the Biodata Catalyst team. And what we're right now doing in terms of tool development is actually working to create Dockers and workflows that who are accessing the BDC workspace can easily utilize. And that includes our NAP pipeline, our Luna tools, and that will enable individuals working within BDC to access sleep data and really achieve some of those goals of improving data formatting, again with tools like an EDF is the raw data files, validator, an annotation or scoring validator, translators and maskers, generating macro architecture, including hypnograms and doing an automated staging, and and generating metrics of microarchitecture, including summary statistics, spectral analyses, and rejecting artifacts. So to actually conclude, I wanted to mention, NSR continues to refine, tweak, and attempt to innovate. But we also know we need the community. And we need overall community support to further develop and share open source tools and support their standardization, addressing issues that relate to intellectual property, commercialization, and scientific rigor. And we really believe it's important to, as much as possible, to encourage, if not require, NIH funded investigators to share their code when possible. But we also know there's a lot of work to be done to educate our communities of multiple stakeholders to make sure we all have similar understandings of the values and approaches for data sharing and optimal approaches for sharing data upfront that would facilitate collecting high quality data that's easy to harmonize. And we understand that there are real roles of our professional societies to adopt and implement some of these upfront standardization procedures. And we really appreciate that NIH has adopted this new data management and sharing plans. And I think as people are implementing this, we think it's very important to modify and ensure that those principles that we talked about today are incorporated and really used as people, as researchers, follow their data management and sharing plans. And I want to emphasize that NSR invites any NIH-funded sleep researchers to work with us as you're developing your data sharing plan or trying to implement it. And we are very, very happy to help work out plans for standardization, as well as providing a home for your data that will increase the NIH's return on investment. So I just want to conclude by acknowledging our wonderful staff, and again, a big shout out to Sean Purcell, and also big deep appreciation for NHLBI